Alright, kiddos, so today we are going to continue with our study of unit rates. Just a reminder, yesterday we did Math Excel, and some of you turned it in, some of you did not. Make sure that gets done by Friday, 70% or higher. Today we're going to be working on section 2-2. So I want you to open or get on to page 92. Okay, so 92, so we're still, again, continuing in volume 1. Alright, so our learning target for today is I can calculate unit rates involving fractions. Okay, so that's going to be our focus today. So process will be the same. We're still looking to make equivalent fractions or equivalent ratios, but we're just dealing with fractions instead of decimals or whole numbers. So that's where that term complex fraction comes into play. Okay, so we talked about it when we were dividing fractions. And we talked about it earlier last week when we were looking over vocabulary. So I got a complex fraction. Okay, so that's your fraction in numerator, denominator, or both. Okay, so that's going to be our complex fraction. It looks really difficult, but we know that a complex fraction is just showing the division of two fractions. So you might see this. Or we could see something like this. Or it might even see something like this. Okay? So those are different examples of complex fractions. Fraction in the numerator, fraction in the denominator, or both. Okay? And we know that this is just showing division. So with that being said, we also are going to see complex ratios, okay? And complex unit rates or complex rates, where we might have fraction in the numerator, fraction in the denominator, or a combination of one of them. Okay? So that's a lot what we're going to see today, and we're going to use these to help us solve our ratio problems. So again, we're on page 92. Sarah Jo is training for a triathlon. What's a triathlon? Very good. Very good. Swimming, biking, and running. Now there's all different types of marathons. There's all different types of triathlons. You can do a sprint triathlon. You can do the entire Ironman triathlon. The Ironman triathlon is swim, bike, and run. Well, yeah, they're all swim, bike, and run. But I think it's like swim 2 miles, bike 112 miles, and run a marathon, which is 26.2 miles. So, fun fact. No, I've never done one. I'll drown the first round in because I'm not a very good swimmer. I can swim. I can keep myself afloat, but I'm not swimming 2 miles, right? So, you think you can, but think about swimming 8 times around the track.
Swim 8 times around.
Yeah, okay.
That sounds hard.
Yeah, okay. Yeah. Okay, well, I'll fill the pool up out there and you can get going. There was a kid, his name is Chris, and he was the first individual with Down syndrome to complete an Ironman, and he did it this year. Very cool. Very, very cool. Mama, the Down syndrome mama in me was like, crying like a baby because it was so cool. Now, individuals with Down syndrome have low tone, so low muscle tone. So that means...
Hey, Sadie.
Yes?
Do you have Savannah Ellick?
I do. Do you need her?
Yes, I have her for a minute, please.
Yep. So they have low tone. So that means that their muscles aren't like, their muscles don't function like ours do. So things that are really hard for them, walking, running, biking, swimming, physical activity. So for this guy that has Down syndrome to complete a triathlon, stinking amazing. So cool. But, so you can look him up on YouTube and, you know, I can look him up on YouTube, I'll cry in front of you. So, but just really cool. Yes, Sam?
Is it bad that every time I hear that name for the announcement, I always get scared?
That it's for you?
Yeah.
Yeah. Absolutely. No. Is it bad? Nah, it's just, yeah, healthy fear.
It's just scary.
Healthy fear. All right, so Sergio's training for this triathlon. His target speed is 25 miles per hour when he's on the bike. Did he achieve his target speed for the first 7 miles of his ride? Okay, so in 7 miles, that took him how much?
15 minutes.
15 minutes. So we're looking for 25 miles per hour. So our ratio is miles per hour. So our ratio is going to be miles per hour, right? So miles goes in the numerator,
Minutes goes in
hours goes in the denominator. Okay, so the ratio that we have right now is 7 miles
every
for 15 minutes. Whoops. U-T-E-S. Okay. Min-U-T. Okay, minutes. I'm in minutes right now. How do I get to hours in this case?
every 60.
Okay, 60. So I could just set this ratio
60.
to 60 minutes, correct?
Yes.
Okay, how do I get from 15 to 60?
You have to multiply.
We have to multiply. Look at the clock right now. Okay, oh, now here, let me do this. 12, 3, 6, and 9. These are 15-minute increments, right? So 1, 2, 3, 4. So there are 4 15 increments in an hour. So 15 times 4, very good, gives me 60. So if I multiply this by 4,
Yeah, that goes like
good.
7 times 20.
Okay, go ahead.
28.
28. Okay, so now I can convert this minutes. 60 minutes is?
An hour.
Okay, did he reach his goal?
Yes. My man said, you want to see some real speed?
He's above his goal.
He was above.
Okay, he wanted to go 25 miles per hour, but he ended up going 28 miles per hour.
Oh.
Okay,
It's on a bike.
apparently he's a really good biker. I think like average, like if you're really like an average person, if you're really pushing it, you like, my husband does the pedal to the point every year for the MS Society. So well, it used to be called Pedal to the Point. I don't know what it's called anymore. But he would start at Brunswick High School and they'd bike all the way to Cedar Point. And like his average speed was like between 17 and 18 miles per hour. And he's just like he does it once a year. It's not like he doesn't bike every weekend or he's not a crazy biker. But like, so yeah, 28 miles per hour. That's pretty intense, right? That's just 8 miles faster than what you go through a school zone. But 28, yeah. So this is one way to do this problem. Okay? Now, the other way that we can look at this problem is 7 miles in 15 minutes. 15 minutes is actually how much of an hour?
Quarter.
A 4. Does that change my process at all?
No.
No. If I need to get to 1 hour,
It used to be 4 fours.
okay, how do I get from 1/4 of an hour to an hour? Times 4. So I'd have to multiply by 4/1, or just 4, because you can do it in your calculator. So we would do the same thing. It takes our middle step out,
And it just 7
you know, because it does. It takes our middle step out, but that's okay. Sometimes you're going to be able to do that, sometimes not. So, you know, 28 minutes, like if it was 28 minutes, do you know the fraction of 28 minutes of an hour?
No idea.
Well, 28 over 60. So you divide by 4, so 7/15 of an hour. You know, I mean, you could do it. You know, but we have the tools that sometimes we can do it in minutes and sometimes we can do it in hours. Right? How did your book do it? Oh, they did it this way. All right. So let's look at Sergio again in our try it section. Sergio now has increased his target speed to 30 miles per hour. Yeah. Not doing that on your mountain bike, right? Okay. So, how many more miles does Sergio need to ride in 1/4 of an hour to achieve his target speed? So in this one, we scaled up. We scaled from 15 minutes to 60 minutes, or 1/4 of an hour to an hour. Okay, so we scaled up because we knew that we needed to go from here to here. So smaller number to a larger number. Now because Sergio wants to increase his target speed, he knows he wants to go 30 miles per hour. So now we have to scale down because he's breaking it down into a 15-minute increment, which is 1/4 of an hour. So Sergio goes from 1 hour to 1/4 of an hour, so he divides by 4. So 30, if we divide by 4 down here, we're also going to gotta divide by 4 up here. So if I've got 30 over 4, okay, couple different ways we can do this. Okay, real easy on this calculator. Okay, so if you have your handheld calculator, to convert an improper fraction to a mixed number, 30 ABC 4, and that converts it for you. So in your calculator, you could go 30, ABC button, click enter, seven and a half. Okay. Now, Desmos,
Just have to click the little button.
I really just need to, I need to put it here.
Still need to get taller.
Get taller.
Yeah. I mean, I'm pretty short, so I can't talk. Oh, you're gonna know that.
I don't know the, oh, I'll have to do that later, but I'll do that. Here we go.
Oh, it's for your bones.
Okay, so if I go 30, AB's, oh, hold on. Okay, so that gives us 7.5. Does it give us 15 over 2? So it doesn't give us a mixed number. Do I care whether you put your answer in a mixed number or an improper fraction? Does the state test care if you put it as a mixed number and improper fraction? Nope, we're okay with it. In the context of the problem, knowing that 15 over 2 is 7.5 is a good idea, but is it necessary all the time? No. Okay? So, 7.5. So he's going 7.5 miles per hour, so he can reach that 30 miles per hour. So, Sergio must ride 7.5 miles in a quarter of an hour to achieve this target. So he needs to ride an additional half mile for a quarter of an hour. So he needs to go 2 more laps on the track in 15 minutes to reach his goal. I always relate everything like miles into the track because it's easy to. It's an easy calculation. But do you guys still run the track in
It's so much better than the inside,
inside?
Yes, because it feels so much shorter.
especially.
It feels shorter.
Especially when it's like 35 outside, because it's just perfect temperature.
My favorite story about my sister is my sister is not an athlete, right? Like my brother and I were the athletes. I was a gymnast. Lee was a wrestler. My sister was in the arts, so musical theater, choir, band. I mean, she's a professor of musical theater. That's her job now, right? So she was not going to pass gym if she didn't there's like some calculation. She had to run the mile in like under 8 minutes and 30 seconds or something like that. Well, I know, but if you're not an athlete, if you're not trained or conditioned to do that, 8 minutes, 30 seconds is a big deal. So I remember my sister, she was probably in like 10th or 11th grade or something like that. She had to run the mile. She crossed that finish line and she blew the chunks. She blew chunks and she missed school for like 3 days because she was so sick after running her mile in under 8 minutes and 30 seconds. Best story ever. Hilarious. Yeah, I think so. Literally. 8:20. I think, yeah. Oh, yeah. Yeah. But that's like her like crowning achievement in high school. That she ran the mile in 8 minutes, 29 seconds. And then she missed 3 days of school after it because she blew chunks. Yeah. Hot topic of conversation, class reunion, I'm sure. Yeah. Yeah. She wasn't, my sister was not like me. Not at all.
Wait, what if she wanted?
We are like polar opposites. What?
But if she wanted to do like the arts and stuff, or why she choose gym for her class, or she just.
She had, it's a requirement. And she put it off. Yeah. So, you know, things happen. All right. Bronwyn mows the lawn every other weekend. She can mow 12,000 feet squared in 2/3 of an hour. The lawn is 36,000 feet squared. How long does it take her to mow the entire lawn? Okay, so her rate is 12,000 feet squared in 2/3 of an hour. Right? So the lawn is not 12,000 square feet. How large is the lawn?
36,000. So that's how many acres is that?
Ah. Okay. How? So the question, how long does it take her to mow the entire lawn? How do we get from 12,000 to 36,000? Okay, we're going to multiply. Now, if you don't know what to multiply by, what do you have to do?
Divide.
Okay, you can divide. You can set up an equation. So 12,000 times some value is going to give you 36,000. Okay? So you can divide both sides by 12,000. And you'll get your value. So if you don't know what that factor is that you have to multiply by, you know how to solve this one-step equation in your sleep now. Okay? So you can do that if you need to. So what's our factor? What are we going to scale up?
How many hours it takes to
Right? We're going to scale up by 3 because 12,000 times 3 is 36,000. So if I multiply this by 3,
to the bottom.
I have to multiply the bottom by 3. Okay. So if you have your hand held, okay, if you have your hand held, 2 ABC3 times 3.
2.
Is 2. Very good. Same thing if you're using Desmos. Okay, so if you're using Desmos, 2/3 times 3, that's going to give you 2. So it's going to take her 2 hours to mow the lawn.
That's a pretty long time.
So again, we're using ratios to solve real world problems. Okay? Now, this would be good to know if you have a side hustle and you mow lawns, right?
Yeah.
Okay? So anyone do that in the neighborhoods? Okay? You mow lawns in your neighborhood for how much you can charge, right? Right? So you could either charge by the square foot, you could charge by the lawn, or you could charge by the number of hours that it takes you to mow. Okay, so those are different rates that you could use to make money.
I don't know if I want to know.
You don't? Put your earbuds in and mow? I mean, I don't. Takes so
My
much time.
neighborhood is.
You're doing a push mower. All right, so Bronwyn's brother Daniel mows every other weekend. He can mow 15,000 feet squared in 3/4 of an hour. Who mows the lawn in less time? So what's our ratio for Daniel?
15,000 over 3/4.
Very good.
The other girl does it. What? The other girl does it.
Okay. Now, what's the problem with this one?
They're not compatible.
They're not compatible.
So you're gonna get a decimal.
Okay, they're not compatible. Okay, so you're probably going to get a decimal. Okay, you might get a decimal. So our issue here, again, the fact that they're not compatible numbers, that tells us that we need to go a different direction. Okay, so let's think about it logically. Could I get here?
Kind of. Yeah. If you divide by 3.
Not by 4. Divide by 4.
You can't read.
What would I have to divide 3/4 by to get here?
3/4.
Any number divided by itself is 1. So I could do this. Any number divided by itself gives me 1. So I can do the same thing here. If I divide by 3/4 in my denominator,
You have to divide by 3/4 by
I can divide by 3/4 in my numerator.
You get 20,000.
Okay? So if I do 15,000 divided by 3/4,
You get 20,000.
yeah, you get 20,000.
Yeah.
How does that information help us?
By saying I pretty much have to do a whole another 15.
Okay? Well, Bronwyn mows 36,000 square feet
In 2 hours.
in 2 hours.
It'll be 40,000 feet.
Okay? So Daniel mows how much in 2 hours?
40,000 feet. person does it faster.
Mine would be 5 miles.
So smart.
Okay? Sophie. This is Daniel, by the way. Sorry. This is Bronwyn.
So, I don't know. Daniel's.
Bronwyn.
Brown. Who names their kid Bronwyn?
It's a family name.
It's an interesting name.
No. Okay, so do we know exactly how long it's going to take Daniel to mow the entire lawn? We don't, but the question didn't ask that. The question asked,
Just who mows?
who mows the lawn in less time?
Brown one.
Okay,
You just said the problem that is already
okay. It takes her 2 hours to mow the 36,000. It takes him 2 hours to mow 40,000. So all the question asks is who does it faster, and we know it's Bronwyn. We don't know the specifics, and that's okay. We can eventually calculate the specifics using decimals and things like that, but we don't need to worry about that. We need to find something that's compatible to just be able to answer the question. Okay, this is going to be an estimate for them, right? So it's not so important that we focus on, in a problem like this, that we focus on the specifics. We just need to get a general idea because we don't need to know the specifics. Yes, correct.
I'm confused on how it would be Brown.
Because
Daniel knows 40,000.
Oh, no, you're right. You're right. I'm sorry. You're correct. You're correct. It's going to be Daniel.
Yeah, I was like,
Here, sorry.
I was very
I was
confused.
confused.
No, you're okay.
But I don't get it because
Wait,
then,
what?
you know, the lawn is 36,000. So how would Daniel mow more than how much lawn they have?
Because it takes
He doesn't mow, he's not going to mow more than what they have.
Oh, yeah.
He doesn't have to, he is mowing, like he mowed an extra 4,000 in that 2 hours.
I get it.
He mowed an extra 4,000, or he can mow an extra 4,000 in the 2 hours.
Okay.
So that means that he does it faster because his rate is faster. Okay? So if we look at this, here's another way to look at it. Okay, look at our unit rate. 36,000 in 2 hours versus 40,000 in 2 hours. So 36, that's going to be 18,000 square feet in 1 hour. He can go 20,000 in 1 hour. So he's mowing 2,000 more in 1 hour than she is. So he's going to go faster. Okay? So again, where did I get back to, guys? I got back to a unit rate. I got back to my home base. Okay? And I was able to easily compare after I made the mistake. Right? That's okay. I make mistakes. I'm not perfect. I know that. But you can, we got back down to our unit rate. And sometimes unit rate's easier because when we compare 1 to 1, it is a little bit easier for us. All right. Let's halt there. Yeah, let's halt there and then we'll go. Is today Wednesday?
Yes.
Hump day.
No.
Remember those commercials?
Let's go for homework, page 95. And let's go 7 through 10. Sound good? Yeah. Okay, we have 10 or 11 minutes. What can you do in 11 minutes? You can get started.